The company that I'm presenting today is Sasken Technologies Limited. A lot of ground to cover. I'll quickly get on to the presentation. First, some important disclosures. Yes, me and my family hold investments in Sasken. Been tracking this company as it's there in the disclosures. Sasken was my first employer. I was employed with the company between October 2006 and Feb 2009. So that's roughly 2.5 years. Post that, there has been no association with the company on any commercial transactions with by me or my family. Uh, yes, so there aren't much public disclosures available on the company, nor is there an analyst, any analyst tracking this company. So there's a lot of secondary research that has been done, and I've tried my best to, make sure that the information is credible enough. But still, I would suggest, if at all anyone is interested, to please cross-check every fact which are being presented in this presentation. So, Sasken has a good 30 years of history into embedded. What is embedded? Basically, putting any intelligence into an hardware or a silicon is requires embedded coding. Okay, Sasken, it's very important for us to understand a company's history to get a perspective to the DNA of the organization. So the journey at Sasken started, when the 3G technology was introduced in the telecom domain in 2001. So 2003 to 2005 was the foundation year for Sasken, where it was investing into IPs for mobile handsets much ahead of the mobile boom that followed. It was very closely associated with TI's OMAP processors and became an exclusive licensee for that. It was during this period when both Nokia and Nortel had put in investments into the company much before, way before it went to an IPO. So at that point in time, there were three verticals that Sasken had: semiconductor, where TI was the anchor customer; network equipment vertical, where Nortel was the anchor customer; and then mobile devices, where Nokia and Motorola were the anchor customers. What happened is 2006 to 2009 was the golden era for Sasken, because you saw the revenue scale up by 3x at that point in time. Sasken was associated with all the top five mobile handset companies of the world. It had its IP in devices coming out from NEC, Panasonic, Motorola, Lenovo, and company was earning a royalty fee out of it. Uh, at one point, almost 7% of the handsets that were shipped in the world had carried Sasken's IP. So that was the IP portfolio that the company was trying to capitalize on, which it had built much ahead of the mobile boom. So at the peak, top five customers, accounted for close to two-thirds of the business, and this was largely dominated by Nokia and Motorola. What had happened in 2009 was three big events happened for Sasken, and this was more specific to the industry rather than to the company. One, so Symbian was losing out to Android and Windows, okay, and two-thirds of Sasken's business was on Symbian at that point in time. So there was a mobile handset devices which was getting disrupted. Number two, what was also happening was, in the network equipment space, there was a massive consolidation that was happening, and Nortel being a large customer, and it had become significantly large in size through acquisitions, leveraged buyouts. So because of the consolidation in the industry, the competitiveness of Nortel was being challenged, and that had kind of financial implications for the company, and the company eventually went and filed in for a bankruptcy. So Nortel was a large customer for Sasken, which was again on a ramp down mode. And third, even in the mobile baseband chipset space, where TI and Freescale were the largest player, their newer players were emerging, and the industry was getting fragmented. And there again, there was some disruption. So you had all these three disruptions coinciding around the same time, which led to multi-year revenue decline. Now, this decline could have been far more significant if not for Sasken's investments in emerging verticals. So during the best times, right, Sasken had two JVs formed, one for automotive electronics and one for consumer IoT, industrial IoT business, basically machine to machine IoT. Now, both these investments were much ahead of time. The industry was still in its infancy. Sasken had spent that investment just to get a grip into how it can position its capabilities in these industries. Eventually, both these JVs folded up, but I think Sasken continued to invest in these verticals. So what had happened is, even during the most challenging period, it went and acquired a company in US called Engineering Technologies, which was predominantly into automotive electronics and consumer electronics. So these were the kind of investments that the company was trying to make in, and there were outcomes, there were initial deal wins also in these verticals. So the company had won some smaller contracts with some marquee Japanese names during this period in both in automotive, and then there was another major win in the satellite communication. Now, this is a vertical which the Sasken had completely built organically. It got a chance to make the world's first commercial satellite phone with Inmarsat. This was sometime in 2010 and 12. And this was a pretty long engagement that they had with Inmarsat, because this was the first time that there was a commercial rollout of a satellite device. So all this was happening parallelly when there were inherent disruptions in the company's core portfolio. What had also happened in 2014 was one of Sasken's key customer in China, which accounted for 50% of the CDMA market in that region, stopped paying royalties for using Sasken's IP in their devices. So there was a litigation around it, and Sasken had won a case against them with a compensation of 2.76 billion rupees. And this, I think, is a big testimony to the value of IP that the company has built. In fact, there were also instances of monetization of these IPs also during this period. 2017 to 2019 was a most important phase for Sasken, because it was pivoting its business model from being just focused on mobile devices and network equipments to semiconductors and automotive industry. Now, these were the emerging verticals at that point in time, and the reason being, Tesla had introduced, the Model 3 version, okay, for the mass market for the first time. This was sometime in 2016, 2017, and it showed the world what an automobile can transform into, basically a software on wheels. And I think this was like an eye-opening event for the industry, and Sasken was, had done quite a lot of work even prior to this event. And when this at around this particular time, what Sasken did was they opened a development center in Detroit to catch up on all these emerging technologies that were unfolding. So that was one. And also during this period, Sasken had won one more large landmark deal in the satellite communication, wherein it got a chance to build the first LTE based satellite terminal device. Okay, now this was with a Japanese OEM called NTT Docomo. So all these, while the investments into newer verticals continued, but I think there were a lot of deal wins also happening in these space parallelly. And I think it was during this period when Sasken also tied up with emerging chipset manufacturers like Qualcomm and MediaTek. Both were, emerging companies. They were not so significant yet then, but I think Sasken was good enough in spotting these companies during this particular time and had a partnership with them. Just when things were taking off, I think COVID hit, and because Sasken is dependent on ER&D spends by the end customers, which took a pause during COVID, I think there was an impact on the business also. So again, you had a phase where there was a pause in activity, but I think investments in IPs continued. So Sasken had roughly about 56 odd patents around this time, and that scaled up to 70 during this period. So investment in patent also continued as Sasken caught up with these newer emerging technologies. So 2024 is when I feel there was a significant turn in the company where a lot of new developments were planned. I think last 2-3 years there have been a lot of developments, which I think I'll talk about that in detail in the subsequent slide. So broadly, with this history, what are the key takeaways for us? Yes, Sasken has been forward-looking in terms of investing in emerging technologies. They were way ahead when it came to capitalizing on the mobile handset revolution. They were way ahead when it came to investing in automotive, consumer IoT, and industrial IoT businesses. And also on the satellite communication side, it was way ahead in catching up with the emerging trends. IP creation and monetization is core to Sasken's DNA. We'll also see that in the subsequent slide, how there were recent acquisitions that the company had made to strengthen its IP offerings. The company has been associated with best of best customers. You take up any domain where Sasken was into, it has worked with best of best customers across all the domains. An important thing which I wanted to highlight here is its association with Japanese OEMs. Now, it's not easy to work with Japanese tech companies, right? And Sasken, all through its journey, has partnered with a lot of good companies in Japan and done quite a decent amount of work. NTT Docomo was the company where the Sasken built the first LTE-based satellite device for them. Coming into partnerships, yes, Sasken was way early in spotting up emerging technology leaders and collaborating with them, and those were instrumental in winning businesses for Sasken. So, for example, the association with TI helped it, scale up significantly on mobile handset. It was associated with many first in the industry when it came to satellite. I've already spoken about it. It in 2017-19, it got associated with Qualcomm, which today is a very dominant force in connectivity, and I'll talk about that in detail in the subsequent slide. Now, the vulnerabilities to Sasken's business model, one is it has always had some high level of customer concentration, which is typically the case with any smaller company that is growing. So that has been the case, and Sasken has taken enough measures to kind of even this out, and also uh, the engagements with customers were always of a shorter duration, right? So customers used to come to Sasken only for doing some niche core work, and it was never a continuous long multi-year kind of engagements, which Sasken realized and took steps towards that. So let me talk about, from 2024 till 2026, what were the steps taken by Sasken to, to capitalize on the capabilities that it has built and also to plug in the gaps in the capabilities which existed. So firstly, on the organic side in 2024, what the company did is to address, the concern what I had highlighted in the earlier slide, where it had, shorter engagements with customers. So what it did was it had 60 accounts. The idea was to take these 60 accounts to a $4 million scale in about 3 years' time. Now, this is a strategy with its conceptualized. Obviously, it is an aspirational one, but I think the directionally that strategy takes care of a lot of problems which the company inherently faced in its business. So in order to execute the strategy, what it did was there was a value chain extension which it did, where it basically extended its core embedded product engineering services into cloud native digital services. Okay, now this helped company tap into a lot of GCCs which are coming up both in India and the Asia Pacific region, and also tap into the hyperscaler platforms where there was a lot of investments happening into these new technologies. So that is a value chain extension that it did. Second, as I had highlighted in the earlier slide, it has always associated with best of best companies in Japan. Now, one learning that Sasken had was many of these companies wanted to have their core technology closer to their centers of development. Okay, so they wanted to have an onshore development rather than working remotely out of India. So Sasken had opened a delivery center in Japan, where in it has a sales team which are all Japs, at the front end, and then the execution will be split between Japan and India. So FY26 is the first full year of operations for this particular Japan center, and there are results coming out of it. And in order to execute the strategy, it was very important for the company to significantly ramp up its capabilities. So it went to expand the office spaces at 3 delivery locations in India. It increased its headcount by 50%, not just on the execution team, but also on the sales team. So it ramped up the sales team in North America, Europe, and Japan. This besides, it also felt there was a need to get in these necessary certifications in to strengthen its offerings in the automobile domain. And I'll talk about then why these certificates are so important. ASPICE and TSAC, these are very, there's a big one-time upfront cost involved in these certifications, and it was necessary for it to get some of the critical businesses from the automobile OEMs. So as you can see from the chart, the count of employees had ramped up by 50%, and which kind of had an impact on its margins also. And there were, inorganic acquisitions also which were there, which is also sitting in this particular cost. Now, what we are seeing here is in the last 2 quarters, we are already seeing that inflection point in the company's organic business, where you're seeing the margin kind of getting normalized. Okay, so you had 12% margin in Q2 of FY26, and that it further improved to 17% in Q3 of FY26. Now, what led to this improvement was there was, if you see, this is the quarterly run rate of of the revenues of the company that had doubled up following the execution of all these strategies. And after 17 long years, today Sasken has again come back to the same scale where it was in 2009 at a far lower headcount. Okay. There's still a lot of catch up to happen on the margins because there's a cost entailed towards inorganic expansions, integrations, and upfront investments towards certifications and licenses. Now, the best part is this particular growth has come with a from a broad-based client. So, you know, in 2009, it had 90 odd active accounts. Okay, now that had reduced to 60 in 2024. This has again gone back to 80 in 2026. Okay, not only that, the number of larger accounts, more than $4 million plus accounts, that has increased. The count has increased from 1 to 5. So is the case with accounts in the bucket of 1 million to 4 million. Now, the customer concentration is also significantly come down, with the top two customers now accounting for just 17 odd percent and the top 10 customers at 60%. So I think it's a pretty healthy growth, a broad-based growth that the company has seen as part of its organic execution strategy. Now, coming to inorganic expansions. So in a span of 18 months, the company had made two acquisitions. Okay, one small, which is Anup Silicon. It is now renamed to Sasken Silicon. Now, this particular acquisition was done in March 2024, where the company was basically getting the custom ASIC capabilities. So think about this way: Sasken, all its journey has worked on the chipsets, right? Now, this was the first time it was, going further one step upstream, wherein it was designing these chipsets also on which it could further build up embedded, do the firmware drivers all the way up to UI and cloud. So that is one capability that got added. And second is Box, where Box is predominantly an ODM player, original design manufacturer, where they were making devices which were eventually getting rolled out in the market. Okay, so that's a downstream capability. So with both these acquisitions, what has happened is Sasken has been able to offer entire offering right from chip to cognition to device. Okay. Now, along with this acquisition, what has happened is it has also added quite a lot of valuable patents, which I will talk about them. So basically, there are 26 patents that came along with Anup Silicon, and these are patents where there are royalties earned out of it even today, and I will talk about that in a while. And then even device ODM business had patents because of its rich history of being associated with a lot of these device manufacturers. So today the patent portfolio is about 20 or 200 plus odd patents. And one important thread, which is common for both these acquisitions, was both these businesses were very niche in their respective domains. They were doing really high-end work, but they did not have a sales team to take this forward, number one. And also, because you are just offering something very niche, they did not have, the end-to-end value chain which is needed to tap in these larger customers. So both these companies, there was a one-man sales team, which is the founder, who were also leading the execution team. So that was a big limitation that they had. And access with larger customers was also limited because of their size. So that is something which got plugged in. And Sasken, for buying out both these companies, right, they spent 400 crores from the 700 crores of cash reserves. Now, this is the biggest investment committed by the company in its history. And this has happened in a span of 18 months. Now, let me talk a bit more on Sasken Silicon. So, Sasken Silicon is a company which was started by Dr. Anup Savla. He is a PhD in wireless designs. He's been associated with best of best chipset manufacturers. Before starting this company, he was with Qualcomm, and while he was with Qualcomm, he was heading the connectivity chipset team for the Qualcomm. And there are several patents that Anup Savla has, which you can actually search and find for yourself, that these are patents which came in when he was with Qualcomm. After he left Qualcomm, he formed this company called Singularity AIX, which is now being folded into Anup Silicon, which is now renamed to Sasken Silicon. So they have a 200 plus member team based out of Ahmedabad. Now, when this business was acquired, the scale of this company was just $2 million, but half of that scale revenues were coming from IP royalties. Now, what these IPs are, so basically Sasken was buying these 26 IPs that the company has. Now, these are predominantly analog IPs. Now, what is analog IPs? To put it very simple, what we see around us, what we see and feel around us, is something is all analog. So if you need to capture all these signals, uh, process it, analyze it, and then perform the requisite action. So this is all, that the IPs that Anup Silicon has does it. So that is one. Second thing, if you look at all these new age industrial applications, some key parameters or some key demands by these industrial IoT applications is, firstly, is on the power side. So everybody wants to have something which can consume as much as possible less power. Two, you also want to have something which has, the connectivity is extended beyond, the usual bands. Three, you need to have far more accurate GPS tracking, right, for some of these assets in the industrial arena, right? So Anup Silicon has these IPs which can cater to these demanding needs of the industrial IoT world. Now, the best part about these IPs are they are also listed, they are cataloged in the global foundries, okay? And there is already an IP royalty which is coming from the use of these IPs by the global foundries. So, that's the portfolio that the company had acquired. Now, what custom ASIC is? So, to put it in simple terms, today, if you take a generic chipset from, say, Qualcomm, MediaTek, NXP, that chipset comes with multiple functionalities, okay? Because these chipsets are ultimately used by multiple end industries. Now, if you are an industrial customer and you are very much focused on the performance or the efficiency coming out of the chipset, you don't want to have the overheads in the chipset. You just want to retain the core circuitry which does the work that you want. So it's basically an application specific integrated circuits that the company designs, and these are all custom made based on the end application needs, which varies from customer to customer. You can't have volumes over here. These are niche needs, which needs to be tailored. The solution needs to be tailored for each customer. So that is one. And because these are doing the specific task, I think the power consumption, efficiency, performance is all significantly higher than a generic chip could offer. And most importantly, what happens when you have a custom ASIC is your IP gets protected because you're hard coding the algorithm and the logic into the silicon wafer. So it's very difficult for somebody to reverse engineer this whole design part. So your IP gets protected, which is today the need of the hour for many systems companies. Now, what happens to the cost over here is there is a huge upfront cost in developing these chipsets, no doubt, but then the unit cost at volumes is significantly lower than what a typical chipset would cost when you're buying from the likes of Qualcomm or MediaTek. So these are the advantages of having a custom ASIC. Now, why did Sasken make this acquisition? So there was an inherent need which was there with the Sasken's existing customers to have custom ASIC capabilities. And this was the reason why this was a quick deal for Sasken. Number one. Number two, it's again a natural extension of what the embedded capabilities the company has. Instead of working, if you can work on multiple marquee chipset names, why not have work on your own custom ASIC chipsets? So this is an upstream acquisition which I had spoken about. And obviously, as you had seen in the past, Sasken has always has that wants to have a rich IP portfolio, IP based revenue stream. And this is something which can enable Sasken to build a portfolio around it. And lastly, it's a full stack capability. So today, if you can actually design a chip, build a software on top of it, the firmware, UI, and also have cloud applications around it, you are basically capturing the entire value chain. Okay. And your engagement with customers becomes far more deeper, and there's a good level of mutual dependency that comes into place. So I think this is the best part of the business, where you can actually have a full stack offerings. And how this helps is, basically this is how the business model works. So you win an ASIC design, okay? Now that typically takes 3 to 6 months. It's an NRE fee, non-recurring earning. Basically it's a one-time non-recurring earning for designing the chip. Once you finish designing the chip, it goes to a foundry where the tape out happens, and then it enters into a final mass production, and then the supplies happens to the customers. Now what happens is, you get a revenue out of NRE for the designing the chipsets, number one. Number two, you are also getting a revenue from the supplies of these chipsets because of your collaboration with these foundries. And number three, you're also getting a chance to have your IPs built into these chipsets where you can keep getting a recurring annuity fee, which will support your future patents, okay, investment in future patents. So the beauty about this business model is the more contracts you win, the you can replicate these designs far more efficiently and try to reduce on the cost and become more competitive in the market. So that is what differentiates this particular business model to the usual business model that Sasken was having. And then there's a recurring annuity fee that you keep getting as long as the product is in the market. As long as you're supporting the product for the entire life cycle. So there is a recurring fee that you come get from the existing base and also for the new supplies that you make. So I've tried to capture that in this particular model. So these contracts does require investments, but then after a point you hit an inflection point where there's a huge operating leverage and non-linearity that comes into play. So what are the early outcomes of this particular acquisition? Anup Silicon, or rather Sasken Silicon, has become 3x in scale in the current year. Last year it did $2 million. This year it did 6 million, more than $6 million for that matter. And the best part is, bulk of that ramp up or the scale up has happened from Sasken's existing customers. Perhaps the reason why it made sense for Anup Savla also to merge this business with Sasken. So all this ramp up has come from Sasken's existing customer base, and not only that, the company has now won 3 full stack IoT contracts. Exactly trying to benefit from this virtuous flywheel business model that it has. Now these contracts are still under execution, and we should start seeing the benefits of this in the next 2-3 years coming from it. So this business, it's been 2 years since Sasken has acquired this, and we're already seeing the benefits of that. Coming to Box, now Box is a very interesting business. So this company was started by Mr. Harish Ramana. Now he is an ex-Motorola. Before he formed this company, he was heading a 3,500 member team for Motorola building mobile phones across Asia Pacific region. Okay. Now, if you recall, Motorola was one of Sasken's largest customers in 2004, 5, 6. And since then, and Harish was closely involved in with the Sasken team even at that point in time. So it's a 20 long years of association that Mr. Harish has had with Sasken's core development team. Not only that, when Mr. Harish left Motorola, a good 35-40 member team followed him to Box over a period of time. So, and let me tell you, this particular team continues to be part of Box and now part of Sasken. Okay. So, roughly 15 years with Box and another maybe 5, 10, 15 years while they were with Motorola under Mr. Harish. So it's a good 20, 30 long years of association. This team has been cohesively been working together, and we don't really get to see such a chemistry in any organization. At least I have not come across such strong team continuing to be with an organization for such long time. And I'd actually personally validated this through a LinkedIn Sales Navigator, where I have the profile of these companies and these employees and how they have been associated with Mr. Harish all this while. So Box also has a great history. Okay, so when the Box was formed, they were the sole system integrator for China Mobile in 2009, and this was a time when they were also closely working with Google's Android platform. And let me tell you, Android was not open source yet at that point in time. So Box has built a lot of IP switches for Android, which are still today part of the platform. So they have been very closely associated with the whole Android platform, which today is a dominant platform for most of the device applications, right? This besides, I think Box, when it started its journey, it was doing a lot of mobile devices. It has made the first phone for Intel. The Lava phone was made by Box, designed and manufactured by Box. They had also developed phones for AT&T in US markets. They had developed phones for Reliance Industries in India. Likewise, they had also been a part of a lot of wearables also. For example, the Fossils watches is something which is designed by Box and supplied by Box. So they've had many such great associations. Okay. Now, one more important part which I wanted to share was when I made a mention about this team, right, which is the 35-40 member team. Now, this team has been with Box for this long time, despite Box facing several financial challenges in its journey. So Box is just not ODM, right? So Sasken has just acquired the ODM part of business from Box International. Box had other co-founders also who had other business verticals, and there were challenges at that point in time. So this team has gone through all those challenges and still remained with the organization. So this team today costs roughly about $3.5–4 million is a annual outflow towards this particular team, which is quite significant given Box scale. Box is just about $40 million business, of which 10% is just this particular team cost. I'm not even counting the other teams which is part of the software and the sourcing verticals. So today Box has two divisions. One is a software division, which is a $12 million business, and one other is ODM for $30 million. In software, it does the same work what Sasken does. It is associated with all these chipsets, Qualcomm and MediaTek predominantly being the two customers it has in its software vertical. Now in the ODM, it does work for the customers like Honeywell, Juniper Systems, Pepper and Fuchs. So what has happened with Box is it was always an asset-light business model. It never had its own manufacturing capabilities. All it was leveraging was it had a strong sourcing team in China, which was leveraging the ecosystem in China and Vietnam in getting things manufactured. So earlier it was very much into consumer products, but what had happened is over the period, because of proliferation of all these EMS players in China, the volume business and consumer business is always a volume business, right? So it became very difficult for Box to compete with these EMS players which are operating at a much larger scale. So over the years, Box has moved out of consumer devices and are now solely focused on in enterprise-led devices. So that's why you see most of the customers where Box is now associated with is all for the enterprise led devices, which are rugged handled devices predominantly. And I'll talk about that in detail in a while. So now let me tell you, the synergies which are coming out from this particular acquisition. So on the hardware side, okay, we know that Sasken was associated with this large customer in Japan where it had completely designed this LTE-based satellite terminal device, right? So there was an opportunity that came to Sasken to manufacture these devices. So what Sasken did was Sasken went to scout for vendors outside to get a quote which it could see if it could compete with the other EMS quotes that the customer had. Unfortunately, it was completely out of sync with the EMS quotations that the customer had received, and this was a multi-year business opportunity which was lost for Sasken. Now, in case of Box, so there was an opportunity that came from Qualcomm, okay, to make an infotainment cluster for a large two-wheeler OEM. Now, this was because of Box association with Qualcomm that this opportunity had come in, but Qualcomm had completely built, designed the whole infotainment module, okay? But because of its balance sheet size, it could not execute this particular contract to manufacture the same, although it had the capability. And this opportunity went to a company in China called Quectel. So both the companies had such instances where they had lost a big opportunity because of certain capabilities that they lacked. Now, because now both the companies come together, I think you get a large balance sheet size which is there with Sasken. There's a good cash reserves which can be leveraged should there be a need. And Box also gets access to a big pool of embedded engineers that Sasken has, okay? And that was always a challenge because of its small size. It failed to attract talent which was needed to scale up the software part of the business. So let me talk about the software piece of the business now. So Box was running an ODC for Qualcomm and MediaTek, okay? It was a 200 plus member team for Qualcomm and roughly 40–50 odd member team for MediaTek. Sasken was also running an ODC for Qualcomm. It was just a 100 odd member team. Now, when both the companies came together, this team becomes a 300 plus member team. And today it is the largest ODC center for Qualcomm in India, and Qualcomm has a very large development team out of Hyderabad. So today Sasken becomes the largest extended arm of Qualcomm, and it is working on all their chipset series, okay? So it's working on all 400, 600, 700, even the 800 high performance computing chipsets Sasken is involved in. So the work that Sasken does for Qualcomm now is basically developing the new chipsets and also supporting and providing maintenance support and updation services for the existing chipsets not just for the Qualcomm, but for the Qualcomm's customers also. So today, for all the chipsets that are deployed by Qualcomm to its customer, when there's a development work that happens around these chipsets, and these chipsets have to be integrated with the larger systems, there are issues that come in for which Sasken comes into picture. So today, this is one piece which is become a very strong for Sasken as a whole, and this piece is something which is helping Sasken tap into multiple other opportunities. So why I feel Qualcomm's relationship is critical for Sasken now is because today Qualcomm is the largest player when it comes to connectivity chipsets. So all the end markets where you have connectivity, be it mobile phones, be it automobile or your IoT devices or the networking platforms or your wearables, Qualcomm is a significant leader, followed by MediaTek and Renesas also. So Sasken does have an association with MediaTek. There is a similar work done with MediaTek, Renesas also. They have worked on Renesas chipsets also in the past and also on NXP's chipsets. So, but today Qualcomm is a leader and is winning business in the market, and Sasken is a big beneficiary of that particular business. So one of the things that have happened post the acquisition of Box is because of this combined capabilities have become so strong that last quarter, that is the December quarter, Sasken, when it reported its earning, announced this multi-year deal win with a large hyperscaler in US for building an ODC center for their wearables division. Now, well, there are very handful of names, okay, which you can think of: Apple, Google, and Meta are the prominent ones which are into the wearables. They did not disclose the name, but any of these names still becoming is a significant win for the customer, for the company. And coincidentally, it's only on the same quarter that Sasken reported highest ever deal win of $57 million. I'm assuming that a significant part of this would be attributed to this particular win. So we already have initial wins on the software side. Now, let me talk about the Box hardware business in detail. So as I told you, Box had exited the consumer electronics part of the business. Now it's only focused on enterprise-led mobile devices. And this is predominantly the rugged handheld devices where Sasken, where Box feels it can position itself well. And let me talk about it. So this is a very interesting market. It's a $5 billion industry, okay, growing in high single digits. And the key driver for this particular industry is this rapid industrial digitization that is happening in. So it's a two-tier market where you have the brand owners. There are very handful of brand owners which I've tried to list them out. And as you can see, each of these players are they are very large in specific end markets, or they are very significant in the specific end geographies. So it's a very handful of players, and it bodes well for Sasken to be in this kind of an industry setup. Now, the next level is you have these ODM and EMS players. So Box, Mdur, and Winmate are all ODM players, where Cypher, Chainway, and Urova are all EMS players. By the way, Chainway has now been acquired by Mdor, so that way it now has manufacturing capabilities which it lacked earlier. So how does Box differentiate itself with these players? So as I was sharing with you, that Box has been part of the Android platform even much before it became an open source. So it has all those GMS certifications which are very critical to get the best out of this particular platform. Number two, it has these important ATEX and IECX certificates. Now, what these certificates are, you need to have these certificates to be able to make a device which can operate in an hazardous or an explosive environment. So all these industrial environments can be classified into 22 zones, from 0 to 22, with 0 being the most explosive zones. So today, Box has those certifications to make devices which can operate in zone 1 and zone 2, which is predominantly your oil and gas majors, your petrochemical plants, or maybe the mining industries, okay, where you have these devices which to track certain parameters where human interventions may not be possible, or maybe you have these devices which can call out for preemptive maintenance as and when needed. So that's a great capability which not others have it. And thirdly, the association with Qualcomm, as I was sharing, they have been, they have access to all the latest chipsets of Qualcomm and probably can get the best out of these chipsets based on the end application needs. Fourth, this is a very important thing. As I was sharing, Box in its initial days had made mobile phones for catering to multiple geographies. So it has those multi-band radio certifications with the telecom carriers, and that is needed because most of these devices are also communicating with the telecom towers, right? So these certifications are also quite instrumental in winning contracts in multiple geographies. Lastly, it's an asset light model that the company has. Now, this is both good and the bad. Why I say good? Because, see, unlike a consumer devices, right, which is where you have large volume manufacturing and the manufacturing is not seasonal, you have continuous manufacturing month after month. Now, enterprise led is not that way, right? So, enterprise led, you have lumpy contracts coming from the customer depending on the need in the end market. So you can't have a continuous manufacturing. So if you have a manufacturing setup, that fixed cost can hit you if you don't have a large contracts coming out of executed out of this manufacturing setup. So that way this asset light model works well for a small company like Box. And on the other hand, if you have multiple contracts, then you can be far more competitive if you have own manufacturing, which is not the case with Box today. So what I've done is I've tried to benchmark Box capabilities with all the other players just to assess, how strong these capabilities and how strong these capabilities can be for Box to win contracts. The financials of all these players are shown in the column below. Box is a tiny player in the market. Okay, today it is just breaking even because there's a huge cost associated with the design team, which needs volumes to absorb. So I think the only way this business can be good for Sasken is if it is able to win some niche, hard to replicate, certificate heavy contracts. Okay, if it's able to win those, then I think this business can do wonders for Sasken. It so far it's just been 3 quarters of reporting where we haven't seen any new wins as such, no major new wins. Smaller wins are obviously there, but there are no major new wins as such today, which is part of Box. So I think this is still a work in progress. So if I have to summarize, all that we saw that the Sasken was doing in the last 2-3 years, the organic strategy is certainly played out, and I think we are seeing the margin normalization that is now underway. The inorganic strategies, Sasken Silicon is already yielding good result. There's been a 3x jump in revenues. There have been 3 full stack contracts that the company has won, and now the execution is underway for these contracts. We have also seen the Box software division, how it has helped strengthen the Qualcomm ODC center and also get a new ODC center for the hyperscaler in US. It's only the ODM piece which is still a work in progress because we haven't seen any material new wins over there. So that's how these strategies have played out so far. Now, I also want to bring out 2 interesting tailwinds for Sasken, and I feel company can significantly benefit because of its capabilities now it has. First being the software-defined vehicles. Think about it this way. In 2007, Nokia had a 40% market share in the mobile devices. Now, at that time, Nokia missed viewing a mobile phone as a software. Okay. Now, exactly the same movie is being played out in the automobile, right? So I think today your automobile is basically a software on wheels. Thanks to Tesla for showing the world what over the air updates are and what it is to have this flexibility of enabling functionalities as and when needed. So not that automotive electronics were not there before the SDV era. There were a lot of ECUs which were there in an automobile, and it was part of a very complex architecture. You had something like 70 to 150 ECUs in a vehicle, and each ECU was performing a specific functionality, okay, and it had to be integrated into the entire system in a very complex manner. And these ECUs were connected with a CAN bus communication system which had bandwidth limitations. So the processing level capability was also limited. So what used to happen earlier was, once the software is hard coded into the system, there was no way you could add additional functionalities to that particular vehicle during the life cycle of the vehicle. You couldn't add any additional functionality, and any software update required a physical visit to the dealer. Now, how this changes in the today's software defined vehicle arena is, you have 3 to 5 high performance domain controllers replacing these multiple electronic control units which are there in the vehicle. Okay, now these domain controllers are now performing the same task of a ECU, but in a far more synchronized manner. Okay, so your software today is completely decoupled with the hardware. So you can actually have real-time updates pushed to these domain controllers and also have functionalities added to it as and when needed. So I think this is the transformation that has happened. Thanks to Tesla for showing the world what an automobile could look like. Now, this is a $50 billion industry, and this is, you know, this is going to have a secular multi-year 25-30% kind of growth rates. Okay. And there are multiple engineering services that are going to open up as part of this SDV offerings. Where Sasken stands out is the connectivity side. I mean, it is pioneer in this particular domain, and it has also done quite a lot of work on V2X and ADAS, also not to the extent as it has done in case of connectivity modules. Now, again, because everything revolves around the chipset, it's very important to understand who is leading the race in this. So before SDV, you had NXP, Infineon, and Renaissance, which are dominating the ECUs, right? Now, all these companies are playing a catch-up game, but today it is Qualcomm and Nvidia which is leading this SDV boom. So now Qualcomm is the only company which has a unified cockpit with an ADAS and a connectivity platform on a single chip. Okay, no other company today has that kind of a chipset. Of course, developments are underway and there are so many things that are happening around. But today, Qualcomm is clearly leading the race given the design pipeline it has. So NVIDIA is more into high performance computing, and they are more stronger on autonomous vehicle and the luxury car segment. Okay, Mobileye, it's an Intel company which got recently demerged out, and they also have a very strong capabilities, but more on ADAS domain, not on the entire SDV stack. So today, if you see Qualcomm's automobile revenue stream has doubled in the last 2 years, and the company is further guiding that it will double in another 3 years because of the $45 billion design win pipeline that it already has. Now, the same $45 billion that it has today, this was just $15 billion 2 years back. 6 months back, this was $35 billion, and now it is a $45 billion. So a lot of OEMs are now, getting along with the Qualcomm's chipset. So more business win for Qualcomm in the automobile. Naturally, that business or Sasken becomes a major beneficiary of it. So uh, now, so if you have to understand more detail about Sasken's positioning in this vertical in the ECU era, Sasken was very strong on infotainment, telematics, and the connectivity modules, to some extent V2X. Now, in this SDV era, all these capabilities, right, they have further got more deeper and more concentrated. Okay, so it's the cockpit domain controllers, the connectivity controllers, and the multi-mode connectivity stack, because today you have multiple modes of connecting to an automobile, right? Through a mobile, through an cellular network, through a Wi-Fi, through a Bluetooth. So all these capabilities is something which Sasken has been working on for the last 20 years. And I think it is very well positioned to benefit from this trend that is happening in the automobile. So strategic enablers for SDV for Saskens are the association with Qualcomm, which I've spoken at length. It is also associated with other chipset players also. A lot of the work, the past work, ECU that Sasken had done was on other chipset platforms. The A-Spice and the TSAC certificate, which I had mentioned earlier, which company had invested in 2025. Now, these are the certifications which are must if you have to be in the SDV arena, because a lot of these chipsets directly have an impact on the safety of the automobile, right? And hence, it's very important to be in compliance with these certifying bodies. Sasken has worked on multiple OS platforms. I think just to QNX platform is something which Sasken has been associated very long, because earlier BlackBerry was a dominant platform, right? Before Android came in and took over. So when Sasken became a partner with BlackBerry in its investor calls, okay, had proudly made a mention about Sasken being associated with Sasken. This was, if I remember right, it was sometime in 2012 or 2014. And I think that speaks about the capabilities that Sasken carries in this vertical. And lastly, this Everest SDV engineering, I don't know how relevant it is, but I think this is a body which I saw multiple OEMs and tier ones make a mention about, where they had basically classified companies which can benefit from SDV. Of the 28 companies that they had listed, Sasken was one among them. And I really don't know the relevance of it, but I think I just thought of, if at all there was a good study done around it, I think this is a great credibility that Sasken has because of a mention about this. Now, they have won multiple deal wins on the SDV pipeline in the recent quarters. I've just listed what they had shared in their quarterly releases. Now, coming to NTN, which is your non-terrestrial network. Now, how do I put it? So, before all the connectivity technologies which were there, be it your cable or your fiber or your telecom, required an upfront investment to be made before you could get users to use it. Now, with NTN, right, the infrastructure is already there. It's already there in the orbit of the Earth. The user just has to look up. So now, thanks to all the LEO satellites, which are the constellation of LEO satellites which are around the Earth, which can be leveraged to have seamless connectivity across platforms. Okay, so that is what NTN devices can do. Now, the best part about this is, I think this is a very niche, small industry at $10 billion, but it can go multifold, because what happened with the mobile revolution, right, in early 2000, can happen with NTN. So, and unlike mobile, because the proliferation of mobile was very gradual, from mobile devices to IoT devices to industrial IoT and to your automobile. Now, in case of the satellite communication, this can happen at a very significantly faster pace, because there are already standard protocols which can be deployed seamlessly across platforms. So the applications can be just not with mobile, but can be with IoT, with agriculture, with maritime, aviation, also with rural connectivity. So multiple end applications can come in. Now, why I feel Sasken is best placed, it unlike automobile, where it is only focused on specific domains of SDV, in case of NTN, it is there end to end. So both with Inmarsat and with NTT Docomo, the company had built a device end to end, okay, including there was testing carried out across multiple locations. So it has a proven track record of being associated with many first in the industry when it comes to satellite communication. And hence, I think as and when developments evolve in this space, Sasken will be best placed to capitalize on it. Just recently, in the first week of March, you had this famous MWC conference, right? And I think this is the most influential conference when it comes to connective devices. So where Sasken had showcased its 5G NTN user terminal. Now, this particular terminal, I want to make a mention about a company in Finland which the company had acquired. The acquisition happened in 2004, where Sasken had acquired Nokia's R&D team in Finland. Today, this particular center has unmatched capabilities when it comes to RF design and antenna designs. And I think this is very critical when it comes to satellite communication also. So I think there are great strategic enablers with Sasken to capitalize on this opportunity. Its association with Qualcomm, the acquisition of the custom ASIC capabilities that company did, it can now also manufacture the device because of box capabilities. It has so many patents to ride on to get the specific end needs for the customers. So I think if at all this theme picks up, Sasken should benefit. And I think there have been some initial wins, but they are not so significant enough. Now, quickly coming to the corporate governance side, well, I've tried to benchmark. It's a very small company, just a $200 million company. You have much larger blue chip names like Infosys and TCS, 5 lakh, 10 lakh crore market cap companies. Okay, so I've just tried to benchmark the corporate governance of Sasken, a small cap company, with the larger names to see where it stands. And I was myself quite surprised to see that 75% of its board is an independent board, okay, which is something same with the case of Infosys and TCS. And the best part is all these independent directors that the Sasken has are from reputed academia and industrial backgrounds. Not only that, their audit team is completely independent. It's shared by today. It's shared by Mr. Sunnimal, and again the entire team is independent. It has a very strong history of having a high attendance of these independent directors at its board meetings. Okay, it's 95% plus. Okay, even in case of Infosys, it is not so high, and I think that is a great sign of how deeply involved the independent directors are in the company's operations. It has again had a clean track record of no audit, no zero qualification. I think one important point which I missed pointing out was